Welcome to episode 12 of Travelling Science. G'day legends, welcome back to Travelling Science, the podcast that's sharing science with the world. My name's Crowe and I'm the Travelling Scientist, coming to you today from Vancouver in Canada. I'm a health science communicator, and on this podcast we interview researchers, doctors and experts, hearing their stories and sharing their ideas that can help us to live smarter, happier and healthier lives. This week's guest is marine ecologist Dr. Alex Thomson. She's a science communicator, a superstar of STEM, and she's working at the University of Technology in Sydney, or UTS, on fighting climate change and protecting our planet. And a lot of her work revolves around algae and how it can be used to improve our world in so many ways. During our discussion, she answers questions like what is algae, why you probably eat algae every single day, how we can make a better beer with algae, microalgae versus macroalgae, what's the difference between algae and land plants, and can we use algae to replace crude oil? And we also discuss things like biological plastics, seaweed farms, seaweed gin, blue beer, algal blooms, protists, dugong grass, carbon capture, algae ink, and even fermented algae. So without further ado, let's get around it. Get excited to learn all about marine ecology and how it could be used to save our planet with the one and only Dr. Alex Thomson. Alex Thomson, welcome to Travelling Science.
Thanks for having me.
It's an absolute pleasure. Thank you for taking the time to be here today. Just to get started, would you like to tell us what exactly did you study at university?
So I started off actually studying a Bachelor of Health Science or Biomedical Science. And I thought that I was going to work in hospitals, work in human genetics, potentially work in pharmacy. I kind of started with that broad stroke approach. I knew I liked science, but I didn't really know where I was going to find myself. About 2 years in, I realised that health was not really the thing for me. And I had an amazing lecturer who came in one day and basically kind of said, the health of people doesn't matter if the planet is on fire. And that kind of triggered me to go, oh yeah, I think I'm actually more interested in the health of the planet than the health of people. Which is a pretty startling revelation for a 19-year-old to have. But I'm sure a lot of people, now, like 20 years later, it's not quite 20 years later, but that sort of time, it's exactly the sort of thing that a lot of people are probably thinking about right now.
I did the exact same thing. I started studying health science with the overall goal to cure a disease one day. That was like the big goal. And then as you're in university, you're learning more about the health of people and also the health of the planet, and you start to realize, oh, maybe with the growing population we don't need to be saving so many lives, maybe we need to be focusing on other things. So I had a very similar situation. I totally understand that.
Yeah, so I kind of went, okay, no, this isn't for me, and changed universities, changed degrees. So I ended up studying a Bachelor of Environmental Science and then at UTS, and then I did an honours year where I kind of pivoted a bit because the honours projects are on offer. I really wanted to be outside, and there was one that was really focused on doing marine work. And I was like, oh yeah, I think I want to spend a year outside and kind of really get my hands dirty. And then it was just like, after I kind of entered the ocean, that was it. And which makes a bit more sense given that I grew up on the beach and I grew up going to the beach and snorkeling and all sorts of stuff. I don't know how it took me that long to piece things together. And then ended up, so I did an honours year in marine ecology and then moved into doing my PhD in marine ecology and biogeochemistry. So all up, after all the kind of twists and changes and bits and pieces, I spent 11 years at university.
That's incredible. You must have learnt a wide variety about a lot of different things in 11 years. What exactly are you doing now? My understanding is your current position is the Industry Engagement Manager for the C3. Can you explain what that is?
Yeah, so the Climate Change Cluster, which is what we call C3, is a research institute within the Faculty of Science at UTS. And their research is really focused on how do we mitigate climate change, but also how do we adapt to climate change. So there's things, how do we develop tools that maybe help us address different aspects of climate change? How do we monitor? How do we manage? How do we restore different ecosystems? So it's a really diverse kind of research group. It's really interesting. And my job is really to kind of help the researchers have their research make impact. So that might be with partnering with an industry partner to help get a particular tool on the shelf, so we can kind of, make a new plastic that addresses microplastics, or the fact that, make a bio-based plastic. Or it might be that we partner with a government organisation to help roll out a restoration scheme. Or it might be that we partner with like a global company to kind of spin out, a particular technology to then kind of help that create impact in, say, carbon capture. So it's a really nice role, because when I was a researcher, the one thing that you kind of always hope is that your research goes out and makes a difference in the world, or a difference in the environment. And this role is really kind of helping to kind of bridge that gap between research and actually getting it in the hands of people that can help make a difference.
Yeah, I'm sure you would be able to see firsthand exactly your efforts going towards building something that could potentially change the world. Can you tell us what you're currently working on? Are there any specific projects that are making an impact?
Yeah, there's a few. So there's one project that we've been working on for quite a while that people, it's really public facing. There's a company in Sydney, a brewery called Young Henry's. And so we've worked with them for, I think it's coming up to nearly 5 years now. So we capture their carbon that comes out of their beer fermenters. So when you make beer, it makes carbon dioxide. We've kind of installed a thing where we capture that carbon dioxide and feed it to microalgae, which is grown on their brewery floor. And then we're working out a way to mix that algae with spent grain and feed it to cattle to reduce methane emissions as well. So that one's really exciting, and also something that people can go and actually see on their weekend.
So Young Henry's brewery in Sydney is actually using algae to capture some of the carbon dioxide emitted during the brewing process. This helps the algae to thrive and grow, and then later on it can be added to cow food, which goes on to make the cows less gassy so they don't release as much methane, further reducing carbon emissions. So thanks algae, and thanks Young Henry's. And if you ever see a Young Henry's beer, definitely try it and take comfort in the fact that you're contributing to a world of sustainable beer brewing. Does that make it carbon neutral beer? Is that a thing? Or is that reducing or even reversing the carbon footprint of producing beer by capturing that carbon and then feeding it back to livestock?
Yeah, I mean, so the aim is to make it carbon neutral. At the moment, the setup is very much a pilot setup, so it's not capturing everything. But that would be the aim, is to make, carbon neutral beer, which is pretty exciting. It's a bit tricky when you look at companies and how much carbon they emit and kind of where you stop counting. But the aim would be that you look at a company and go, all right, this is how much carbon it takes to kind of brew beer. And then, implementing these really innovative strategies helps to either make that neutral or, maybe one day we'll be able to make it carbon negative.
Beer that's cooling the planet down. Is there any algae in the beer? Because I heard about using algae in beer production, and my first thought was there's an algae beer out there. And most people would think that's disgusting. I'd like to try it, being a bit of a nerd like that. But is algae beer a thing?
So with the Young Henry's project, no, there is no algae in the beer. It is just a part of their fermentation production process. It's pretty cool because algae essentially does the reverse thing that yeast does. So yeast basically takes the sugar, produces carbon dioxide, and then alcohol, and then the algae captures that carbon dioxide, turns it into a sugar, and then oxygen off the other end. So it's kind of this really nice process. But however, there are algae beers out there. I have seen people do things with seaweed beer and things like that. And there's also people that use algae as a pigment for things. So you can pull blues and reds and all sorts of stuff out of algae. And I've seen people use that in various drinks and things like that as well. I think there's even a gin company that uses seaweed in one of their gins. So, it's out there.
So the Newfoundland Distillery Co. in Canada, which is where I currently am, has a seaweed gin, which is described as refreshing, like being enveloped in an ocean mist, surrounded by a host of pure local botanicals. And it won a double gold medal at the 2018 San Francisco World Spirit Competition. What is a double gold medal? I don't know, but it sounds pretty good. And when I googled algae beer, I came across an article titled, excuse my French, Sacre Bleu, French brewers use algae to make a blue beer, in which they used spirulina to make a blue beer that tasted like beer. Unfortunately, the brewery did close down after that for non-algae related reasons, But they proved that it is possible to make a tasty and colourful algae beer. But algal beverages aside, what else is Alex currently working on?
We're also working on a number of different projects, as I mentioned, with developing new building materials, developing new plastics that are bio-based, so made out of seaweed or microalgae. Your typical plastic, is made of fossil-derived sources. When you're pulling stuff out of the ground, you get your crude oil, you through a bunch of different processes, turn that then into a plastic. That crude oil, realistically, it's been under the earth for a really long time, millions, billions of years. A lot of that is algae that's just been down there for a really long time and squished and compressed and all sorts of stuff. There was a long time where the planet was just a bunch of microorganisms and algae and bits and pieces, and that's all there is down there now that's been turned into a bunch of crude oil. So I think there's been a long history of research into using algae as a crude oil replacement because it's the same, essential oil, and there's been a lot of people turn it into things like fuels and bits and pieces. So the building blocks are there. If you get algae and grow it on land and use it to capture carbon, the building blocks are already there to make something out of plastic, turn it into plastic. So we've been working on a bunch of different projects to grow algae and, essentially remove that destructive process of pulling crude oil out of the ground and grow it on land, and either, grow it in a place where maybe it's a seaweed that's remediating, capturing nutrients in an estuary or something like that. And then we've got all this seaweed or this microalgae and then turning it into plastic, which is either biodegradable or compostable. There's some instances where we actually don't want that plastic though to be biodegradable or compostable because we want to make something that's going to last a really long time and actually hold carbon for a really long time. So there's been a whole bunch of different plastics developed. And really the goal is to make something that is out of a renewable resource, that you're not using a crude oil, source to actually, which produces carbon anyway, to make a plastic.
Yeah, so a more sustainable type of plastic. I know we definitely need to do something about oil extraction, but this algal-based oil that we're currently digging up now from millions of years ago, does that process not take millions of years? Like, is it possible to fast track that sort of process to get that out oil within, say, a much shorter time period, or?
Yeah, no, it's about, I think it's just sort of that the time period it's been down there, there's just so much of it there already. So it's just a process of how do we grow enough on land to then meet our current needs, really. So yeah, there's a way to do it. People have tried, various different ways of doing it. I think it's just, we're getting to a point now where we've got no other choice. You've got to start getting into renewable sources of these sorts of things because we don't have another choice. As I said earlier, like, we've just had the hottest July on record ever as a planet. Was it something like South America was 37 degrees yesterday and it's winter? And, you see all these memes about climate scientists saying the planet's on fire and everyone's like, oh yeah, but literally the planet is actually on fire.
So this episode was supposed to be released last week, but coincidentally, I just so happened to be living in a small town in British Columbia in Canada, which was evacuated due to fire. After a week of 40 degrees Celsius, 105 degree Fahrenheit days, which triggered countless wildfires across the province. So can confirm, the planet literally is on fire. And if you want to learn more about what we can do to put out this metaphorical but kind of actual global fire, listen to my recent episode with climate change expert Professor Andy Pittman. But now, let's talk about algae. What is it? Where does it come from? Will it save us? And can I eat it? Dr. Alex's answers may shock you.
So maybe we'll start with a little bit of an algae 101 because that might help. When people think about algae, sometimes they're not really 100% sure what they're actually thinking about is correct, right? So algae is like a bit of a collective term for a whole bunch of organisms. Algae, they start off, most of them are photosynthetic, but really you can kind of group them into two big groups, the microalgae and the macroalgae. So microalgae are the stuff that you can't see with your naked eye. It covers stuff, that you might, people talk about algae blooms, that sort of stuff, but it's single-celled organisms that photosynthesize, capture carbon dioxide, and they grow really, really fast. They are found everywhere. If you were to take a little petri dish and wave it around outside, you would probably get a couple microalgae cells caught on there because they're in the air, they're in your pond water, they're in the ocean, they grow in all different types of conditions. You get them in like, hot springs, you get them in salt flats, you get them in growing in conjunction with all sorts of stuff. They're everywhere. So there's something between 200,000 and 1 million species of microalgae. So it's kind of like you pick the characteristics you want, and you can probably find a microalgae that'll do it. The other group are macroalgae, which cover off things like seaweeds and stuff like that, kelps. So macroalgae can be freshwater. There's a few freshwater macros, but most of them, when we think about them, are things like seaweeds that wash up on the beach. So both micro and macroalgae have different components and qualities that are useful to us. So you can use a lot of them for food products. They're really good at doing things like capturing wastewater and pulling nutrients and stuff out of it to kind of treat it. And they're really good at capturing carbon. But it just kind of depends on what problem have you got. And we'll find maybe a macroalgae might be more suitable, or maybe a microalgae might be more suitable. When it comes to things like plastics, you can actually use both. It's just you've got to find one that's a bit oily, and ideally one that grows really fast, because that means that you're capturing more carbon. When we're making biomaterials, the aim is always to grow it and to not take it from the natural environment. We kind of want to leave those natural environments and ecosystems to do their thing. And we want to implement ways that we can grow these algae either on land or in conjunction with another system, so it's providing another service. So there's places where people grow seaweed in estuaries, and they grow the seaweed so it captures the nutrients. That's like maybe farm runoff, that sort of stuff. And then they use that seaweed to then make another product off the other end. So kind of implementing a bit of a circular practice.
Very cool. Thank you so much for the Algae 101 lesson. So seaweed is algae. Is that correct? Seaweed's a type of algae?
Yeah, seaweed's algae. Yeah.
So we eat algae. You can eat algae. Algae's healthy, right?
Yeah, look, I think there's there's always going to be some algae that have negative impacts on human health. There's some nasty bits and pieces out there, but that's like saying trees. Like there's going to be some trees that aren't great for humans. There's going to be some that are great. It's that kind of thing. But there's algae in a whole bunch of products and people don't even know about it. So if you've ever had anything with agar in it, that's algae. A lot of toothpastes have algae in it. A lot of ice creams, almond milks use a component of algae as a thickener. Face creams, face masks, you name it. There's a lot of products already out there that have got it in it.
So we're using algae all the time, whether it's in the toothpaste you use to brush your teeth, or maybe it's in your yogurt or your alternative milk, or maybe it's wrapped around your sushi. Almost definitely. To figure out if you're consuming algae, just check out the ingredients list of whatever you're curious about. Carrageenan, spirulina, agar, algin, alginate, chlorella, kelp. Those are just some of the more common algal components that you'll probably find around your house in more products than you might realize. Awesome. You also mentioned some building materials. I feel like something like algae or seaweed might not be the best for building with. Can you elaborate on that a bit?
Yeah, so it's a big push that when we decarbonize, how do we kind of store all this carbon? Where does it go, right? If you're capturing carbon from the atmosphere and you've got it, what do you do with it? You can't just let it go again, because that sort of, creates more of the issue. But there's been a lot of work done on how do we, capture carbon quickly using biological methods, so things like algae. And then what do we use that algae for? We can turn it into things like, when I talk about plastics, that could be plastic like a laminate bench top or something like that. Or we could use it to turn into some type of, when I say building material, I mean like non-structural building material. Yeah, adding it into buildings and things that have like a longer life. So you turn your building into a carbon sink, essentially.
Right. So in this context, you're talking about algae being used as sort of like a carbon storage, in the same way that planting trees and growing trees, like that's another way of storing carbon in the environment.
Yeah, but trees do a really good job of storing carbon for a long time. Algae doesn't necessarily have that same ability to store it for a long time. So we need to turn it into stuff. But it's great at being turned into stuff. So that in that way, that's why we're able to kind of think, okay, we've got all these different species. We've got all these different qualities that these species have. What can we use it for? What can we turn it into? Can we turn it into a fibre that we can then make a T-shirt out of? Can we turn it into a plastic? Can we turn it into a building? Can we turn it into something else? So in that way, we can kind of look and say, what's the best way that we can use this algae and the best way that we can store its carbon?
Yeah, you were saying that you can get pigments from algae as well. So you could probably turn them into clothings, colorings. What else is algae in? Tell me more.
I mean, algae is already used in pigment for a lot of things. I think, like blue food dye is like a really hard dye. It was traditionally quite artificial. And I think more recently it's been made using like spirulina extracted pigment, so it turns it blue. Um, what other things? There's so many things that algae that already kind of exist that people don't even know about. Yeah, I mean, agar is one of the things that people don't realize that is in a lot of stuff that is completely algae based.
And we utilize that in the laboratory all the time.
Yeah, well, yeah. And then there's a whole bunch of really cool companies that are actually using algae to make stuff. So there's a company in the US called Living Ink, and they make printing ink out of algae. They work with companies like Patagonia and things like that. There's companies that, like in WA, there's a company called Ulu that ferment algae and make like a plastic. There's companies that turn it into alternate proteins, like a fake salmon or a fake prawn, because they've got like very similar sort of tastes, that sort of oceany sort of stuff.
And the texture as well.
Yeah. So there's all sorts of stuff.
Right. So if you're out there and you're looking to start some sort of sustainable business that's just doing things in a better way, maybe algae could be the answer. So think about it. You probably already talked about this, but what do you hope to achieve long term with your work and your research?
I think there's so many different aspects of it. Like I think really the thing that gets me out of bed every day is trying to make the planet, address some of the biggest crises that we have, right? So, and that's not to say I'm here to solve the climate crisis. It's not going to be me. It's going to be a lot of people working together. But if I can contribute to, and be a part of that, that's kind of what gets me out of bed in the morning. And I think that, every day that we kind of do that work, if it's me supporting a researcher to get some funding to be able to do something, if it's me talking at Splendor in the Grass and actually inspiring someone to go, hey, maybe I shouldn't go and buy a whole new outfit off an online fast fashion retailer for one music festival, or, something like that, that all kind of makes a difference, right? Someone once asked me, I think I gave like a presentation at a company about sustainable practices and something like that. And someone said to me, like, this is all just so overwhelming. Like, it doesn't really matter if I do anything, right? And I was like, well, it's the actions of all individual people that have got us to this point. So, if we're trying to flip the switch, we've just got to do it in reverse. So yes, every single thing that people do does matter, even if they think it's small or insignificant. So if I can, even just help people to have conversations about stuff. I find it really interesting, like, my parents, are of a certain generation. I'm sure a lot of people's parents are of that generation. And, even just getting my mum to stop using Glad wrap, like, I was pretty happy with that, just little things like that can all kind of have a big, I guess, like rolling effect, it all makes a difference.
Totally. And I know some people can do small things like stop using Glad wrap, start composting. But what you're doing, the work and the research that you've done and the amount of impact you've had, I'm sure, is incredible. So thank you so much for doing what you do. What are some of the biggest challenges that you face in your line of work?
I mean, the stuff that the researchers that I work on is innovative, right? Like it's pretty innovative and it takes time. And I think it takes innovative companies and innovative people to be able to support that. And it can be really scary for some of those companies to go, all right, we are a small business or we are a big business, doesn't really matter what size they are. We're going to do something that is, quite innovative. We're going to start using a new product, or we're going to invest in research that maybe will get us to a new product, or maybe we are going to start changing the way that we do things because we've been given this information that helps us potentially be a more sustainable business. And, I always applaud these businesses that do that because they're doing it off their own back. And really, we kind of need more support from people like governments to make those companies taking those steps, make it less scary. Because if we had more people doing it, these changes would just kind of keep rolling and we would start really making dents in things. I think that's kind of, it's not hard because these businesses are, they're fantastic to work with, but it can be scary for someone to start to take those steps.
Mm-hmm. And that can take a lot of time convincing the right people, which probably requires a lot of research, which also takes a lot of time. So I guess it's quite a long process to to make these changes?
Yeah, and I think particularly over the last couple of years where there's been, businesses have been struggling, a lot, to then make a commitment to something that may not, necessarily benefit their bottom line can also be really scary.
Is there anything that people can do right now to go out and say, embrace more algae in the, all these sort of businesses? Like, is there anything that people can do to support that?
I think people forget sometimes that every time they do something, they're essentially voting, right? So we always think that the big changes are going to happen when you're voting in, the federal, state governments, that sort of stuff. But every time you spend $1, you're voting. So if you're, and it can go as big and hard or as small as you want. But just being aware where you're putting your money is essentially voting. So if there's little things that you can do to make yourself more aware where you're kind of doing that, whether that's looking at where you're buying your clothes from, or looking at where you're buying your food from, or
drinking Young Henry's,
where you're buying your beer from. Exactly. It all makes a difference. And I think I think as we were talking about earlier, a lot of people who, maybe don't interact with the environment in the best way, I think it comes down to awareness, right? And if you're open to being educated and learning a bit more about how to treat the planet in a better way and sharing that a bit, I think that also helps.
Are there any books or documentaries that you could recommend to people that might give them some more information about this whole movement?
There's great stuff. Like, I applaud the guys that do War on Waste. Like, that's amazing. I think that really, goes back to a lot of that stuff about, what can you do as the individual to kind of impact this stuff.
War on Waste is an Australian show that looks at some of the insane waste that humans produce on a regular basis. Like how you might get a takeaway coffee cup in the morning. Think about how many tens of millions of those cups get used across the world every single day. And that is just one example. But the show basically explains what we're currently doing wrong and how we can solve it. So look up War on Waste online and watch a few episodes. It's interesting, it's funny, and it will inspire you to make a positive change in your life. But you know what else is good to watch? Well, I'll let Alex tell you.
If people ever want to get inspired about this stuff, whenever I watch something like David Attenborough's like Blue Planet or something like that, you're just like, oh, okay, well, this is why I'm doing this, right? So that my nieces and nephews can still snorkel out in the water and we can still have, these beautiful environments and spaces.
Is there anyone in particular that inspires you to do what you do?
So I lectured undergrad science for quite a long time, and I think I was always inspired when I had students come up to me and be like, yeah, this is kind of really what I want to do, or I'm really passionate about this space, or I went to a climate march. For me, it's kind of those like younger people who are really kind of hell-bent on making a difference that kind of make me inspired. There's such a wave of change happening, and they're the people that really inspire me the most. I also I have a really young niece and nephew, and to kind of see them when they go to the beach and see stuff through their eyes, it's so nice to kind of see, and you go, man, I really hope that this stuff is still around by the time that they get to my age. And it kind of really does inspire you to want to keep going and make a difference.
That's such an awesome answer. And most people are like, oh, it's someone from 100 years ago or someone incredible. But to actually look to the younger generation and be inspired by that.
All those people are white men, Jesse. All those people are white men,
We're the worst.
We need to talk about the women and Indigenous people that are inspired us, a lot of those people. But, we need more visibility on those people too, right?
Yeah, absolutely. Stepping away from science for just a minute, what do you do when you're not in the lab? What do you like to do, Alex?
I'm a big fan. I spend a lot of time outdoors, so I go camping a lot, go snorkeling a lot. I play basketball terribly. Pretty rounded out answer, but if I can get outside on the weekends or get to the beach on the weekends, then I'm pretty happy.
Sounds like a good life balance. Spending the week in the lab or in the office, and then weekends, just get outside into nature, which is what we're trying to protect here.
In some nature, or listen to some music or something like that, for sure.
Sorry, I got to cut this out. But you know what I hate is when people go out somewhere beautiful and they just take a loudspeaker and just crank music, like in the national park or something. It's like, what are you doing? Just embrace quiet for a minute.
When you go hiking somewhere and someone's got one strapped to their backpack, I hate it. Yeah, awful. I went on a hike not too long ago, and not only was there a group of people with those speakers strapped to their backpacks, but there were people that had left like toilet paper on the hike as well. I was like, come on, guys, like sort it out.
A lot of people are doing good things for this planet. Some people are really not.
I don't know. I kind of feel like if you give people enough like educational tools, it's just a lack of awareness, right? I think everyone has the capacity to do good things for the planet. It's just giving people the tools and the space to be able to do it.
So consider this a public service announcement. When you go out into beautiful nature, don't ruin the serenity. Don't take a loudspeaker and crank loud music because no one else wants to listen to it. The animals don't want to hear it. The trees don't want to hear it. So just don't be that guy. And don't leave rubbish out there. Put it in your pocket, put it in your backpack, and take it with you. Just an idea. Do you have any daily rituals that anything that you need to do every day?
Not real. I desperately need coffee every single day. That is 100%.
Tea. I needed tea like first. As soon as I wake up, I'm like, put the kettle on.
Coffee, 100%. Walk the dog. Get outside. Get some sun on my face, and listen. I listen to a lot of music. It's probably if there's a day that goes past that I don't have my headphones in listening to some new stuff, then that's probably a bit of a weird day. But it kind of depends where I am. I move around a fair bit. So the moment I'm up the coast, and my favorite thing to do in the morning is to make a coffee and then go and sit outside and watch the surfers in the waves, which is like such a nice thing to do in the morning.
Beautiful. Well, Alex, I've got some listener questions for you here, if you'd be able to answer those for us. But before that, each week here on Travelling Science, we make a donation to a charity of the guest's choosing. And this week, Dr. Alex has chosen to donate to the Coral Nurture Program at UTS, which is working to propagate, plant, and grow various types of coral in order to replenish and recover some of the Great Barrier Reef. So a donation has been made to the Coral Nurture Program on behalf of Dr. Alex Thomson. And if you care about the Great Barrier Reef and you'd like to make a donation too, you certainly can. Or if you'd like to support this show and the charities that we donate to every single week, you can certainly do that as well, and that would be greatly appreciated. In both cases, the links are in the show notes just down below. But for now, back to Travelling Science. The first one comes from Microscopy Marina, and she wants to know if there's a difference between healthy algae and algal blooms.
Yeah, so, well, I mean, it kind of depends. So algae blooms usually occur when there is excess nutrients in the environment. It can be indicative that something's off in the environment. And so normally, if you're an ecologist, right, you don't necessarily want an algae bloom to occur, although there can be some instances where there can be a benefit, but generally when we talk about algae blooms, it can lead to negative things like fish kills and deoxygenation.
Can you just quickly explain what an algae bloom is?
Yeah, so it's basically when you have an excess growth of microalgae in the environment. And that can be triggered by a whole bunch of things. You might get too much nutrient runoff, you might get a bit of a heat wave or something like that. Generally, when we're looking at environment, algae blooms not necessarily something that we want, but when we're growing algae for a product, we're essentially growing a large mass of algae with the intent of turning it into something. So it just I think it's that thing of like the right place. If we're growing it with intention on land, for a purpose, that's a good thing. Algae blooms generally not great from an environmental perspective, but just kind of right place, right time, that sort of thing.
True. There you go, Marina. Benjamin wanted to know, well, he says, aren't algae just underwater plants? And if they are, couldn't we just use land plants for these solutions?
Yeah, so technically algae aren't plants. They're from a group called protists. But yeah, they basically act the same way. But plants grow a lot slower. They've got to put energy into doing things like growing trunks, roots, that sort of stuff. Algae, all they do is they're just little bubbles of photosynthetic energy that just keep replicating over and over again. So there's estimates that algae are I've seen numbers between 20 to 40 to 400 times more efficient at capturing carbon than land plants, because that's all they do. They just keep photosynthesizing and replicating over and over and over again. So you could, plants have a purpose. It's not saying that that they, are worse at doing things. They just can be implemented in different ways if we're thinking about carbon capture to something like algae.
Very cool. I can't believe I didn't remember that algae is not a plant. It's a protist.
Well, I mean, we usually just call it a plant because it's easier for people to kind of, it does all the same sort of stuff. But if you're looking at your big phylogenetic tree, if you went to like first year biology at university and they put that big tree up on the board, they're kind of, and there's, where there's fungi and there's plants and there's animals, they're kind of all in that protist space.
It's got its own little branch. Yeah. Very cool. There you go, Ben. Algae are much more effective at growing and converting carbon into what we want. Jeannie Ray wanted to know, and you've already dropped in plenty, but do you have any fun facts about algae?
I mean, I talk about this a lot, but algae is actually one of the things that gave our planet an atmosphere. So when we're talking about like the evolution of our planet over the billions of years that it was able to kind of hold life, one of the strongest things is that, the ability of microorganisms to photosynthesize, so microalgae, is one of the things that they think basically gave our Earth an actual breathable atmosphere. So when we're thinking about climate solutions, it's sort of like that's where we always go, well, algae was the thing that kind of gave us a climate anyway. So we're kind of just reverting back to a solution that's billions of years old.
Right. We wouldn't even be here without algae. So that's a pretty fun fact. I love it. Thank you.
I mean, another fun fact is in every group chat that I'm in, every WhatsApp group, my name is just Algae because Alex and Algae, it's the same two first letters, and all my friends just changed my name to Algae.
Genius. I love that. Well, thank you for answering those listener questions, Algae Alex. Just to finish up, I've got a lightning round.
Ready?
Ready? Alrighty. Being a marine ecologist, do you get to go on boats often?
Not as often as I'd like, but sometimes.
Do you get seasick?
No.
Good. You make a good marine ecologist. If you had an unlimited budget, what area do you think you would most be focusing that? Like, what specific arm of research would you like to put that money?
There's two parts. I think we need to develop quicker, faster, more innovative solutions to capture carbon. And then also more ways that we can restore our native environments.
Love that. If you could do something completely different with your life, if you'd never studied science, for example, what do you think you would have done?
I mean, I love cooking. There was a part of me that spent a good portion of my teen years like cooking in restaurants and things like that. So maybe I would be like a chef that uses like local ingredients or something.
I was thinking a chef that uses algae, but that sounds way better.
Or that,
Always drawn back to the same thing. What do you love most about your job?
I think my favourite thing is when we have been working on something that we think could be really great or really innovative, and then a researcher walks into my office and says, we got it through, we're going to be able to, actually kind of roll this out. That's really exciting when you kind of see that this glimmer of research that kind of could potentially be something and be a game changer, someone picks up on it and goes, yeah, let's do it, and we can kind of, hopefully help some stuff happen.
Yeah, that must be such a good feeling. What's your least favourite part of your job?
I live in Sydney and I wish that I just was able to, when I used to do more research, I used to see the ocean a lot more, and now I'm not doing research much anymore, so I don't get to see the ocean anymore, and I wish I got to see it more.
Yeah, I can imagine. You need more nature. Do you have a favourite type of algae?
I have a favourite type of sea grass, which isn't actually algae. It's called Holophila ovalis, which if you look it up, it's like an underwater little clover.
I looked this up and it is very cute. Holophila ovalis, also known as spoon grass, grows in seabeds and it does look like little clovers or little green spoons. But it's also called dugong grass because dugongs love to eat it. And I was skeptical because the leaves are so tiny and dugongs are the opposite of tiny. But I found a video online of a dugong gorging itself on this grass. Looks like a giant underwater vacuum cleaner. It's beautiful and haunting. And the link is in the show notes. Check it out.
My favourite type of algae is probably something that like a lichen, because lichen is just algae and a fungi in a little friendship. And I think that's just really kind of nice.
Fantastic. Well, Dr. Alex, thank you so much for coming on the show today. You have done incredible work with algae and marine ecology, and I think you're having a huge impact on taking some positive steps that are really going to help us save the planet one day. So thank you so much for all of your work. And I'd just like to finish off with one more question. If you had one bit of advice to give to the listeners that they could take home and act on to improve themselves or the planet in some way, what would your final bit of advice be?
I think it's the thing I've been saying the whole time is that, like, no act is too small. So, this stuff can be really overwhelming. It can be super scary, and it can feel like I just can't even face it to, address anything to do with the climate. But no act, nothing that you do is going to be too small. Everything has an impact. So even if you're just able to make one thing, have one conversation, it's all going to help. And it's up to all of us, really, to do that.
So there you have it, legends. That was marine ecologist Dr. Alex Thomson. And I just love her point of view around individual actions. It might be easy to think that what you do doesn't have much of an impact on the grand scheme of things. What you eat, whether or not you recycle, how much energy you use, how much water you might waste. You might think that all that stuff doesn't matter, but it's the individual actions that got us to where we are today. Everything that you do has a small impact, and those small things add up over time. And if you think that the problem really lies with bigger industries and companies, then remember how Alex said that we really vote with our dollars. So if you think that big companies are the problem, then don't support those big companies. Be more mindful about where you spend your money and focus on smaller and more local and sustainable companies. If everybody did that, it would have a profound impact on climate change. And it all starts with you. And if you want to learn more about algae and how it could potentially save our planet, you can follow Dr. Alex at DRAT_science on Instagram and Twitter to keep an eye on everything they're doing over there at UTS. Also, make sure you subscribe to this show for more travelling science every single week, and follow Travelling Science on Instagram to see who our upcoming guests are, and you can even send in your own listener questions. And if you want to leave a review on the Apple Podcast app, that would be awesome. It helps other people to find the show, and I'd love to hear from you. I'd love to hear your feedback, and I could be reading it out on next week's episode. Finally, if you stick around to the end of the show, I always leave you with a little secret. And this week's secret is that, as you know, I was supposed to produce this show last week, but I actually got evacuated from a fire. I was living in a small town. I was actually living on a farm in Lee Creek in British Columbia in Canada, and we spent most of our week with smoke filling the air, and we had to evacuate all of the animals. So I was chasing around chickens, I was chasing rabbits, I was chasing pigs, I was chasing goats, and getting them all into a truck so we could take them away before the fire came through. And I can safely say that we saved all of the animals, we saved all the valuables, and we got off the property just in time before we got completely evacuated from this fire. And honestly, it was an exhausting week, and it was really scary, but I'm okay now. All the animals are okay. But like Alex said, the world is really on fire. There is wildfires all over British Columbia and all over North America right now. So safe to say my holiday isn't going according to plan. But I think the takeaway from this little end of show secret is that I spent most of last week chasing and wrestling pigs and goats. And that is something I'll never forget. It's exhausting, disgusting, painful, but to save their lives, worth it. Thanks so much for listening, legends. I'll catch you next Science Sunday. Cheers.